Greetings, judges. Our project is CoralWatch, which is based on SDG number 13, an AI-powered reef intelligence platform designed to automate coral reef monitoring using computer vision, geospatial intelligence, and environmental data integration. Coral reefs are extremely important ecosystems that support nearly 25% of all marine species, but unfortunately, more than 50% of global coral reefs have already been lost due to climate change, bleaching events, and marine pollution. Traditional reef monitoring methods require trained divers, expensive surveys, and cover less than 1% of the reefs worldwide. CoralWatch addresses this problem by providing an automated and scalable reef monitoring system where the users can simply upload underwater images and instantly receive coral health insights. Now I will briefly explain how our system works. Let's start with coral health check. Here we will upload some example images. As the image enters our AI analysis pipeline, the image is first sent to the YOLO object detection unit, which scans the image and detects individual coral regions by drawing boundary boxes around them. The coordinates of these bounding boxes are then used to crop each coral region from the image. These cropped coral images are then passed to our ResNet-50 classification model, which uses test time augmentation techniques such as flip and rotation to improve prediction robustness. The model classifies each coral as either healthy or bleached and generates a confidence score. We will take a look at the results now. The accuracy of the YOLO model here used is 86%, whereas the accuracy of the classification model ResNet-50 used here is 98%. This confidence value is processed by a severity engine, which converts it into standardized health score from 0 to 100 and assigns a bleaching stage. In addition to coral health monitoring, the system also performs marine debris detection using a separate YOLO model. This model identifies pollution such as plastic bottles, fishing nets, net foams, ropes, helping to monitor environmental threats after affecting the reef ecosystem. All the results, including the annotated images and environmental data, are stored in a Supabase database and Cloudinary storage systems for long-term monitoring. We can see the results here. The accuracy of this YOLO model was 92%. The processed results are then visualized through our interactive Reef Dashboard, which includes several key features. When a user uploads an underwater image, the platform first extracts GPS metadata from the image using PostGIS geospatial queries. The system identifies the nearest reef location within a 2-kilometer radius or automatically creates a new reef zone if none exists. This allows us to build geographical database of reef locations and historical observations. First, a reef geospatial distribution will be shown that visually represents coral health across the geographic locations. Second, a reef list and a detailed panel that provides in-depth analysis of each reef, including the health score, water quality metrics, and active threat indicators will be shown. When we enter the site directory, we can analyze all the regions with their latitudes and longitudes. So when we enter their zones, it will exhibit parameters like water quality, UV index, etc. Then we can see the health timeline graph. And when we move towards the predictive analysis section, here we can see the empirical correlation graph between thermal stress versus health. And here is another graph that shows the regional health index distribution. Finally, the system also includes data analysis tools, timeline charts, and before and after image comparisons, enabling researchers to track reef degradation or recovery over time. We also calculate our reef recovery rate, which measures how quickly a reef is recovering after bleaching events. Overall, CoralWatch transforms traditional manual reef surveys into a scalable AI-driven monitoring system, enabling researchers, NGOs, and scientists to monitor coral health efficiently and support timely conservation efforts. Thank you. Now we will once look at the databases stored in Supabase and Cloudinary. Thank you so much for your time, judges.